Hello everyone, the topic of our presentation is automatic detection of Russia-Ukraine war euphemisms. Euphemisms are a linguistic device used to soften or neutralize language that may otherwise be harsh or awkward to state directly. By acting as alternative words or phrases, euphemisms are used daily to maintain politeness, mitigate discomfort, or conceal the truth. Despite being an important element of language use, their figurative nature poses a challenge for natural language processing, and in particular figurative language processing. The Russia-Ukraine war gave rise and prominence to a number of euphemisms, especially in the Ukrainian language, such as bavovna, meaning cotton, literally, and explosion as a euphemism. Ptashka, meaning birdie literally, and a drone as a euphemism. Zadvoksotete, meaning to kill, pіти на концерт Кобзона, meaning to die, etc. So the aim of our study is to discover efficient techniques for the automatic detection of Ukrainian euphemisms related to the topic of the ongoing war, which presupposes the completion of the following tasks. First of all, we aim to collect a data set of Ukrainian war-related euphemisms based on the corpus of modern web communication, then to elaborate, standardize, and apply the notation scheme for potentially euphemistic terms, as we call them, PATs. Then we elicit key difficulties in the recognition and annotation of the PATs by humans, and finally leverage machine learning techniques for the automatic detection of euphemisms and assess the performance of the tested models. Previous research studies the phenomenon of the euphemism treadmill, by which words, phrases gain or lose euphemistic meaning over time, especially develop negative meanings over time. Also, researchers may not agree on what euphemisms are. Some researchers treat code words as euphemisms as well. Automatic detection of euphemisms was studied by a number of scholars. You can see them on the slide, and they mostly proposed euphemism detection and identification based on using masked language modeling with BERT. Nowadays, however, it's more appropriate probably to focus on large language models and to apply prompt engineering for them, which means testing both zero-shot prompting and a few-shot prompting accompanied by illustrations and enabling in-context learning of the model. In our study, we tested such large language models as GPT-4 Omni, GPT-4 Omni Mini, and DeepSeek, because they showed actually the best performance, and assessed their class-wise performance based on F1 score. The following stages were followed. So first we collected the data set, annotated it, processed it, tested zero-shot and a few-shot prompting, and also applied some prompt engineering to enhance the performance of the models. The corpus used for this purpose is PAWUK, the Polish automatic web corpus of the Ukrainian language, and the seed list of the euphemisms encompasses 21 potential euphemistic terms, which have been collected manually and annotated by 4 annotators. So while annotating and collecting data, we tried to follow some principles. First of all, we tried to get a balanced representation of the paths across the 3-year period. We tried to represent all word forms for most euphemistic and non-euphemistic usages, tried to use a corpus-driven approach proportionately representing different usages, their word forms, etc., and try to identify and include cases hard to classify, such as instances of pun, intentional play on words, vagueness, symbolism, etc. Euphemism data collection is complicated by the polysemous status of the lexemes, or potentially euphemistic terms. Thus, the collected corpus samples required additional labeling in order to disambiguate euphemistic and literal usages. The annotators did it manually, attaching label 1 for euphemistic usages and label 0 for non-euphemistic or literal usages of potentially euphemistic terms. Here you can see the examples of the term bavovna, which euphemistically means an explosion, but non-euphemistically can mean cotton, mass, or flour. Or such words as dvohsotый, trехsotый, meaning dead and wounded, respectively, which can also have literal meaning. The resultant data set is as follows, and you can see that altogether we have annotated over 4,000 potentially euphemistic terms. The inter-annotator agreement was measured using Cohen's kappa, and for the resultant data set it equals to 0.89. The next stage was prompt engineering, and we tested different prompts. On this slide you can see the most successful ones. So first of all, it was a context-free prompt or zero-shot prompt without any illustrations, which sounded as follows: which sentence in the set determined whether the term enclosed in the angle brackets is used as euphemism or not. The next prompt was to label an example: which sentence in a set determined whether the term enclosed in the brackets is used as a euphemism or not, but consider the example. So the large language model was presented an example of labeling. And then there was a prompt with a dictionary definition generated by GPT-4o model especially, yes. And finally, the prompt with a word list of euphemisms. The best performance showed the prompt with a dictionary definition somehow. And the best performance also showed a GPT for Omni, but not for all euphemisms. So here you can see how the procedure took place. On this slide you can see that the labels of annotators and the LLM sometimes disagree, so all these scores were taken into account. The best performance in terms of recall and F1 score was achieved by GPT for Omni for a prompt with a dictionary definition. In terms of precision, the best performance was achieved by GPT for Omni for a context-free prompt. Not bad performance was achieved by GPT for Omni Mini for a prompt with a dictionary definition. Here you can see the results for the individual words or potentially euphemistic terms. So strikingly, all words had a very high performance, with a few exceptions, such as, for instance, ціль, дискотека, відпрацювати, which showed lower scores. As a conclusion, we may say that the best performance has been achieved by GPT for Omni and GPT for Omni Mini for the whole data set while interacting with a prompt accompanied by dictionary definitions of the euphemisms under scrutiny. However, some euphemisms showed different results. The war-related euphemisms on the whole are very context sensitive. They manifest vast creative potential of the users and show a tendency towards becoming negative over time. And it's a problem for both humans, let alone AI. Nonetheless, neural network models relying on the advanced algorithms and proper prompt engineering can facilitate their detection and recognition. This study is part of the broader international initiative within the ImpressU project, DEA, Detecting and Recognizing Euphemisms, which is a supplement to the NSF grant. Thank you for your attention.